Ever wish you could, get a doctor's insight without the long wait, maybe powered by the latest tech?
Uh-huh. Skip the waiting room queue, basically.
Exactly. Well, today we're doing a deep dive into something pretty significant in medical AI. Google's upgraded AME.
Right. The Articulate Medical Intelligence Explorer.
And what's really new and kind of fascinating is its ability now to process visual medical data.
Which really marks an evolution, doesn't it? I mean, previously, AMI was impressive with text-based chats.
Yeah, that research got a lot of attention. We saw it highlighted in Nature.
It did. But a real diagnosis often isn't just about what a patient says. Doctors are constantly looking.
Looking at scans, examining rashes, that visual element is key.
Absolutely. They interpret images all the time.
Okay, so our mission today is really to unpack how Google managed to get AMA to see, so to speak.
And what the early results are showing from their tests.
Right, and maybe touch on the implications for healthcare down the line. We'll look at that text foundation from Nature.
And then really focus on these new visual experiments Google's been running.
Yeah. So for you, the listener wanting to get up to speed quickly, this is about understanding a potentially major shift in how AI could help doctors.
Well, the really interesting challenge Google tackled here was, um, can these large language models, these LLMs,
Which are amazing with text.
right, can they actually integrate complex visual information into that sort of delicate back and forth of a medical chat?
Okay, so let's unpack that upgrade. How do they actually get AMIE to, interpret an image?
Well, our source mentions they use their Gemini 2.0 Flash model, and importantly, something called a state-aware reasoning framework.
State-aware reasoning framework. Okay, that sounds a bit technical. Can you break that down a bit?
Think of it like a doctor taking notes during the consultation. This framework lets AME keep track of the key information as the chat unfolds.
Ah, okay, like remembering what's been said.
Exactly. And it helps Amy realize when it's missing something,
Right.
just like a human doctor would know they need more info.
And then it can ask for it.
Precisely. And now, crucially, that missing information could be visual. It can ask for and then interpret visual data.
So instead of just asking, what are your symptoms?
Uh-huh.
It could maybe say, can you upload a photo of that rash?
Or, do you have an image of your ECG results?
Yes.
And then it can actually make sense of what it's seeing in that context.
And the Gemini 2.0 Flash model is what provides the horsepower for that image analysis.
Basically, yes, it's the engine that analyzes the image and weaves that understanding back into the conversation.
Yeah.
It's not just seeing a shape, it's understanding its medical relevance.
Right, within the context of everything else the patient has said.
Exactly.
Okay, this is where, for me, it gets really interesting. How did they test this? Our source says they built a virtual medical lab. Sounds like sci-fi.
It's actually a very clever approach. They built realistic patient scenarios using real, anonymized medical images from established data sets.
It's like actual ECGs and skin photos.
Uh-huh. Things like the PTB-XL database for ECGs and the SCIN dataset for dermatology images. Validated sources. And they also use Gemini and other AI to help create detailed and, believable patient histories to go with those images.
So they could train and test AMIE in this controlled simulation before using it with real people.
That's the idea.
Hmm.
AMIE was essentially talking to these virtual patients, getting feedback on its diagnostic accuracy, its overall approach, whether it missed anything critical.
Smart.
And then came the real evaluation. They modeled it on the OSCE, the Objective Structured Clinical Examination.
Oh, yeah, that's what they use to test medical students, right?
Exactly. So in this remote study, they had 105 different medical cases presented either to AMIE or to actual human primary care doctors.
And real people, actors, played the patients, uploading images, chatting via text like a telehealth session.
That's right. Mimicking that kind of interaction. It sounds pretty comprehensive as a test setup.
Definitely.
And after each consultation, both specialist doctors and the patient actors reviewed everything.
What were they looking for? Accuracy.
Accuracy of the diagnosis, yes, but also things like the perceived empathy of the AI versus the human doctor. Trustworthiness, too.
Okay, and the results. What did the source say?
Quite remarkable, actually. The findings indicated that AMI performed better than the human primary care physicians in interpreting the visual data and reaching accurate diagnoses.
Better. Wow.
Yeah, specialists apparently noted AMI's strong image reasoning and its sort of comprehensive diagnostic thinking.
That's significant. What about the empathy part?
That was also quite striking. The patient actors often rated AME higher on empathy and trustworthiness in these text chats compared to the human doctors.
An AI rated as more empathetic. That's counterintuitive, isn't it?
It is. It makes you wonder, doesn't it? Maybe it's about consistency or perceived lack of bias. It's certainly something worth thinking about.
But wait, was it perfect? Did AMI make mistakes?
Ah, good point. The source is clear that there wasn't a significant difference in the rate of errors when it came to actually interpreting the images themselves.
So both the AI and the doctors made mistakes interpreting the visuals at a similar frequency.
Correct. That's a really crucial nuance. AMI excelled overall in the diagnostic process in this setup, but wasn't infallible on the image interpretation step itself.
Okay.
And they also mentioned testing with Google's newer Gemini 2.5 Flash model.
Did that improve things?
Yes, apparently they saw further improvements in both diagnostic accuracy and the suggested treatment plans.
Hmm.
So the technology is still evolving rapidly.
Okay, so let's quickly summarize this for you, the listener. The big upgrade for AMIE is this ability to handle visuals using Gemini 2.0 Flash and that state-aware reasoning thing.
Which lets it ask for and understand things like photos of rashes or ECG images.
And they tested this rigorously in a virtual lab using real medical images and AI-generated patient histories.
Right. Then in a simulated clinical exam, an OCE, AMI actually did better than human primary care doctors at diagnosis using visual data.
And was rated higher on empathy and text chats, surprisingly.
Though importantly, the error rate on just interpreting the images was similar for both AI and doctors. And newer models like Gemini 2.5 show even more progress.
So the key takeaway for you is just how fast AI is learning to process different types of medical info text and images now.
But, and this is a big but, the source rightly emphasizes this was research in simulations.
Real-world healthcare is way messier, right?
Absolutely. A text chat isn't the same as seeing a patient in person or even on video, and simulated patients, however good, can't capture all the complexities.
So what's next then? Where does Google take AMIE from here?
Well, the obvious and crucial step is moving out of the lab, testing in real clinical settings.
Are they doing that?
Yes, they've announced a partnership with Beth Israel Deaconess Medical Center to start evaluating AIE in a real hospital environment.
Okay, that's a major step.
It is. And they're also working on adding capabilities to handle real-time video and audio.
Which would bring it much closer to actual telehealth interactions.
Exactly. Trying to bridge that gap between the simulation and the real thing.
This really does feel like a potentially big leap forward, though, giving AI the ability to see as well as hear.
As the source puts it, yeah. It could genuinely reshape how doctors and patients interact down the road.
It opens up so many possibilities.
Definitely. But as the source also wisely cautions, turning these promising early results into reliable, everyday healthcare tools, that's going to take a lot more testing.
Thorough validation, careful ethical considerations.
Absolutely. It's a long road from the lab to the clinic.
So, thinking ahead, as AI learns to see medical information, how might our interactions with doctors actually change?
What new possibilities might open up for diagnosis, maybe even treatment?
It really makes you consider that balance, doesn't it, between these amazing technological advances and, well, the irreplaceable human touch in medicine.
So definitely the big question for you to ponder as we watch this space evolve.